Today, we will be presenting our prototype, the Scary Roomba, a unique device used for keeping animals away from solar panels.
So I will start off by introducing myself. My name is Reb Kellesy. I am a sophomore here at Purdue studying CGT website design, and I would consider my role in the group to be the brainstormer / presenter presenting this presentation.
All right, I'm Drew Kanya. I'm a junior, major systems analysis and design, and my role in the group was doing the PowerPoint, team feedback, and designing the final product.
I'm Max Molik. I'm a freshman in cybersecurity, and my role in the group was prototyping and the engineering.
My name is Arden Friend. I am a junior majoring in human resource development, and my role in the group was facilitator / the point person. Next slide. So our capstone assignment for this project covers solar power energy. In the Midwest, solar farms are abundant and more homeowners are buying solar panels. However, the problem is keeping animals away from building nests, defecating on the panels, and chewing through the wiring. We decided we needed to find a humane solution to keep animals away from solar panels to maximize solar power efficiency. Next slide. We found 5 major stakeholders that are affected by solar power. First, we have homeowners and solar farmers. These two groups are directly affected as they own panels and have to worry about equipment being damaged. Then we have energy-conscious consumers who could be interested in energy efficiency for solar power. Then we have grid companies that work for solar power owners. And finally, we have Purdue professors who are involved with research in solar farms near campus. Here you can see our problem statement, which is solar panel owners need to find a way to prevent airborne animals such as birds and bats and other animals from damaging their equipment.
All right, for research, what we did was we had 3 methods of basically doing the research: literature observation and interviews. And what we learned from literature was that the final product needed to be simple in design and easy to implement, because there are a lot of technologies that are implemented in solar energy, and that's the reason that why it's made to be simple. We also needed to solve messy habits such as defecation on panels and making nests underneath panels. And for observation, we found that solar panels are frequently visited by animals and birds because of the cover that they provide. We also observed that there was maintenance. We saw lots of work being done with wiring and just general fixes on solar panels. And we also observed that there should be something to deal with the nests that are already there. And in interviews, we found that birds defecating on solar panels and living underneath them is a big problem. And the animals messing up the wiring is also a huge problem as well. And for existing solutions, bird spikes and bird wire, both of them are pretty inhumane. Birds get stuck trying to go through the spikes and the bird wire. There's constant repairs being needed on both of them. The spikes aren't really that effective. They're also difficult to install. So it's just generally they're not effective, not easy to install, and they're both inhumane.
So here is our proposed solution. We call it the Scary Roomba, and it is a very humane device designed to scare away animals. So what the Scary Roomba does is it moves around automatically like a Roomba would, and it has reflective surfaces. These reflective surfaces will scare away animals, and it makes constant bursts of loud noises as well, which also serves to scare away animals. It has large wheels with lots of traction on it, which allows it to move across a large variety of terrain. In terms of design viability, this is a fully automated device. So it just moves around on wheels, and it's fairly good with energy. It runs on 6 AA batteries, which will last for about 10 hours at the moment. We're planning on introducing a better charging system for it later, but this is what we have right now. In terms of criteria, it's a very low-cost solution. It would be around $60 to make, and it's pretty effective. The prototype is loud, it's reflective, can patrol small areas, and we're thinking of future additions as well, like waterproofing, GPS, and wireless charging.
So the prototype was built with Legos just due to difficulty of finding parts and kind of a lack of resources. This prototype runs off batteries. In the initial design, it used a microcontroller, but I was unable to find the parts for the microcontroller to control. So we did it out of Legos. Otherwise, it would have been fully programmable. The prototype is able to drive on its own. It was loud and it had reflective foil on it. Next slide. So for testing, the robot was left outside to guard a piece of bread for 30 minutes. The prototype drove in circles around the plate, and no animals touched the bread, and the robot ran for the duration of the time. It did drift a little bit off course just due to a lack of ability to program it optimally, but no animals dared to go near it. And the predicted battery life is about 10 to 12 hours in the current solution. Yep, you can play the video. So this is just a quick clip of it, what it did for 30 minutes. It just drove around this little plate with a little bread roll on it. You can kind of see, but the blacktop is surrounded by like a foresty region. This wasn't like in a town. It was completely surrounded by forest. And if there was audio, you could hear birds chirping and the machine purring. So, all right, next slide. So the next steps would be able to build the robot out of proper components and have a 3D printed chassis. This would allow advanced programming of the robot and allow the inclusion of more features like waterproofing, precise pathing, and more ways to scare the animals, such as flashing lights. It would also have wireless charging and GPS. This would allow it to be tested on an actual solar farm, and a more refined version of this Roomba could easily be brought to market. The GPS and wireless charging would allow the Roomba to be able to follow a set path to patrol any solar farm, and would allow the inclusion of wireless charging stations the Roomba could include in its pathing to charge automatically. This would allow the Roomba to run indefinitely. Also, waterproofing and swappable wheels would allow for all season and all weather operation. The wheels being swappable for treads would allow easy winter operation, as it would be able to drive on top of the snow. Once these features could be tested and implemented, the Scary Roomba would be ready for deployment in solar farms everywhere. And that's all.